Hello friends, this is Dr S D Mitragotri from Department of Chemistry, Walchand College of Arts and Science, Solapur. We are going to deal with something about fundamentals of organic reaction mechanism. Let us start with defining learning outcomes of this session. At the end of these sessions, you will be able to write different types of chemical bond fissions and 6 different types of arrow notations used in the chemistry on regular basis. First, we will start with fission or breaking of cleavage of chemical bond. Covalent bond is formed between two elements by sharing of electrons. During the chemical reaction, old bonds are broken and new bonds are formed. The breaking and making of the bond, it takes place in two different ways, by homolytic fission or by heterolytic fission. Let us see first the homolytic fission. Homolytic cleavage is the breaking of a covalent bond in such a way that each fragment gets one of the shared electrons. The homolytic comes from Greek, where homeos means equal and lysis means breaking. Homolytic cleavage produces free radicals or atoms with unpaired valence electrons. We will see some examples. For example, homolytic cleavage of chlorine molecule in presence of ultraviolet radiation. When we subject chlorine to ultraviolet radiation, the chlorine molecule will undergo homolytic fission. In this bond, there are two electrons. One electron will be taken up by this chlorine, another will be by this chlorine, and they will produce chlorine radicals. Another example, homolytic cleavage of benzoyl peroxide, where benzoyl peroxide, when exposed to ultraviolet radiation, produces radicals, same way as chlorine did. Now, homolytic cleavage of a chemical bond, it is shown with the help of fish-hook arrow, which involves transfer of single electron. The position of arrow tail indicates existing place of electron and head indicates final position of electrons. Let us talk about heterolytic fission. Heterolytic or ionic fission is a breaking of covalent bond in such a way that one of the atom get both the shared electrons. We know the bond is formed by two electrons. So one atom will take away both the electrons, another atom will not get any electron. The word heterolytic, it comes from Greek, again different, heteros meaning different and lysis meaning breaking of the bond. Heterolytic cleavage is most likely to occur in polar bonds, and the electrons will move towards the more electronegative atom. We will see some examples. Heterolytic cleavage of carbon and iodine bond in case of tertiary butyl iodide, where there is a bond between carbon and iodine. This bond is broken heterolytically. Both the atoms, both the electrons, they will go to the iodine because iodine is more electronegative, and iodine will form anion. And carbon, it will not get any electron, so it will have positive charge and it will form cation. Means at the end of heterolytic fission, you will get pair of ions. Not like in homolytic. Homolytic you will get radicals, but here in heterolytic we will get cation and anion. Another example, breaking of OH bond in the water. Here oxygen and hydrogen, they are having a covalent bond. Two electrons are present between oxygen and hydrogen, but when the bond will break, oxygen being more electronegative will take away both the electrons and it will form anion, that is OH minus ion, and H plus, H will have plus charge, it will form cation. So again there is a formation of ions. Heterolytic fission produces ions. Heterolytic cleavage of the bond is shown with the help of curved arrow, which involves transfer of two electrons, not like fish hook arrow. Position of arrow tail indicates existing place of electron and arrowhead indicates final position of electron. Now we will have test of your understanding. Few questions I will ask. You have to pause the video, think of the answers, write the answers, then again we can start this, continue this session. Let us have first question. Okay, you have to predict the type of fission that will take place in the following molecule. When you have hydrogen peroxide subjected to ultraviolet radiation, which type of fission it will undergo. Second example, when you react methane with chlorine radical, which type of fission will take place. The third, when you have methyl bromide subjected to solvolysis, how the carbon and bromine bond will break. The next, when you have methyl magnesium bromide, how the bond between carbon and magnesium will break. So you have to pause the video, think of answers, get your answers ready, have your reasons for your answers, and then in next slide we will start with the answers. So you can pause the video and complete your task. Okay, now let us have answers to questions. First one, when you have H2O2 hydrogen peroxide subjected to ultraviolet radiation, remember here there is a bond between two same elements, so it will undergo homolytic fission to produce oxygen radical. The next one, already here radical is present, so the bond between carbon and hydrogen also breaks homolytically to produce methyl radical and HCl. Remember, it is nothing but halogenation of methane. You must have learnt in your lower class. The next, when methyl bromide is subjected to solvolysis, it produces cation and anion. The bond will break heterolytically. Another example, here when you subject this methyl magnesium bromide to the breaking, remember magnesium is electron donating, so it will donate both the electrons to carbon and carbanion will be formed and magnesium will have positive charge. Okay, now the next part, that is different types of arrow notations which are used in the chemistry. First, the forward arrow or reaction arrow. The forward arrow reaction arrow which is generally used, for example A plus B, it produces C. Here the reactants are shown on the tail side of the arrow and head side indicates product. The next is equilibrium arrow. We know there is a existence of keto and enol form in case of ketones, especially in case of acetone, which can be shown with the help of this equilibrium arrow. The third, the resonance arrow or double headed arrow. When you have benzene, we can represent benzene in 5 different ways, and each structure we say they are resonance forms of each other, and these resonance forms they can be shown with the help of this double headed arrow. The next is retrosynthetic arrow. Here on this side we have reactants and on this side there is a product. So this is shown with the help of such type of arrow and it is called as retrosynthetic arrow. Remember, position of arrow tail direct towards the product and head direct towards the reactant. It is reverse to our regular notation. The next is curved arrow. The single headed arrow depicts the moment of pair of electrons. Oxygen and hydrogen, the bond will break, and the pair of electrons, their migration is shown with the help of curved arrow. Here there is anion and cation. The next is fish hook arrow, which we have already studied. In case of homolytic fission, the bond between two H, it will break by homolytic fission in presence of ultraviolet radiation, and fish hook arrow is shown or it is used to show the migration of single electron. Right? Now again we will have a small questionnaire. The first we have to answer which type of arrow notation you will use for the showing relation between A and B. Let us have first question. Yes, here formaldehyde reacts with OH minus and produce this compound. So which type of arrow notations you will use? The next is there is a structure A and structure B. Which type of arrow notation you will use? You can pause the video, you can think of the answers, write the answers, and then you can have checking of the answers when the next slide. Right, now we will have answers for the first one. Here OH reacts, OH minus reacts with formaldehyde. Remember, here we are showing the curved arrow because it involves transfer of 2 electrons, and again the product is shown with the help of single headed arrow, straight single headed arrow. The next is Yes. What is the relation between A and B? A and B, they are resonance structures of each other. So we know resonance structures are shown with the help of double-headed arrow. So we are going to show the relation between A and B with this double-headed arrow. Right? Now, let us have an assignment for content we have learned so far. Draw the different types of arrow notations used in chemistry with their names. We remember we have studied 6 different types of arrow notations. The next is, with the help of reaction, write in detail the process of homolytic and heterolytic fission. I have used some references. The first is Organic Chemistry by Morrison and Boyd, very famous book. Reaction Rearrangement Reagents by S.N. Sanyal. Organic Chemistry by Claydon Warren, and Fundamentals of Organic Reaction by John McMurray. So you can see this video, try to understand the things, and if you have any queries, questions, you can mail me. My email address is here, sdmitragotri@gmail.com. So if you have any queries, questions, you can directly mail me and I will try to answer your queries. So thank you for watching this video, and we will continue our interactions in future also. Thank you.